Alright, welcome to the chemistry spring final review. What you're going to need for this is a periodic table. I've got a photocopy of this on my canvas you can print out and use if you want, or if you've made your own during this year you can use that, or any other kind of periodic table will work. I also have some other brain dumps that we made in class and are available on my canvas as photocopies. If you bring these in during your exam, I'll give you extra credit for writing them down. Okay, so I have one for how to write ionic versus covalent compounds. I have one for the different types of reactions, and I have one for nuclear chemistry. Okay, there's some more, but they're going to be in video too. Alright, so for now, let's go ahead and start. If you see these little notes off to the side, you can write those in, and whenever they get checked in class, you will get extra credit for those. Okay, so first thing, your atomic number is going to be equal to the number of protons and the number of electrons. Okay, your mass number minus your atomic number is equal to your total neutrons. Alright, then number one, what element is pictured to the left? Okay, the best way to do this is just to look at the number of protons. Okay, so I go to my periodic table, find the element with six protons, and that's right here. So carbon has 6 protons because that's equal to my atomic number, and that's my answer. So the element to the left is going to be carbon. Alright, blank are found in orbitals or outer rings. So around here, these are our orbitals or outer rings. So that's going to be our electrons. Alright, number 5. Ions are atoms which have gained or lost electrons and have a charge. So these little doodads just kind of shift on over to the other elements to form charges and bond together. Okay, how many of each of the following does a neutral atom of fluorine have? Okay, so we're going to go over to fluorine. All right, my atomic number is equal to the number of protons. So I have 9 protons, which means I have 9 electrons because it's neutral. If it weren't neutral, then it would have 10 electrons because fluorine will gain 1 electron. All right, and to find the total number of neutrons, I take 18.998, I'm going to round that up to 19, minus my protons, which is 9, and that tells me I have 10 neutrons. All right, that little n is just an n with a 0 because neutrons have no charge, which leads us to the next questions. What charge does each of the following subatomic particles have? Protons are going to be positive, neutrons are going to be neutral, so they have no charge, and electrons are going to be negative. All right, number 8, an atom of the same element with more, an isotope is an atom of the same element with more or less neutrons. This increases or decreases the mass of the atom. All right, take a second, you can write that down. And then number 10, what 2 subatomic particles can be found in my nucleus? If I go back up to this picture up here, my nucleus is this ball or this cluster that's in the center of my atom, okay? And I have these positive protons and these neutral neutrons, okay? So I have in my nucleus protons and neutrons. All right, down to number 16, or 14 and 15 I've answered for you. Your groups are going to be your columns, and your periods are going to be the horizontal rows. Okay? Number 16, how many more electrons do the following elements need to satisfy my octet rule? Okay, so I'm going to do this by labeling what my group number is and how many valence electrons each one has, because that'll tell me how many more electrons I need to get to 8. So phosphorus. All right, phosphorus is in group 15, so that means it has 5 valence electrons, and to get to 8, I need 3 more. Okay, oxygen is in group 16, so I have 6 valence electrons, so I need 2 more to get to 8. Bromine is in group 17, so I have 7 valence electrons, and I only need 1 more to get to 8. And neon is in group 18, which means I have 8 valence electrons, so I need no more. Okay, your group 18 is called your noble gases, and group 17 is called your halogens. All right, you can make that little note in there if you would like. All right, next page. Number 17. how many valence electrons does aluminum have? So I need to go find my group number. My group number is 13 for aluminum, so that means I have a total of 3 valence electrons. Okay, what will aluminum's ionic charge become whenever it bonds with a non-metal? Well, it's easier, if it's trying to get to 8 to be stable, so it's easier for me to lose those 3 electrons than it is for me to gain 5. So I'm going to lose 3, and whenever I lose those 3, I have a positive charge. Okay, because I'll have more protons in my atom than I do electrons. All right. Number 19. Halogens will have 7 valence electrons. That's what I just said for group 17. Group 17 has 7 valence electrons, and they're known as halogens. Okay. Elements in the same group or column will have similar reactivity. All right. Similarly, beryllium, magnesium, and calcium or sodium will have similar reactivity. Okay, so we're going to look at this. We have beryllium, magnesium, and I'm trying to decide if calcium or sodium have similar reactivity. Okay, they have similar reactivity whenever they're all in the same column. So I'm going to go with calcium as my answer. So calcium, because they all have how many valence electrons? Boop, 2. All right, horizontal rows, so your rows that go across, are known as periods. And tell us the number of energy levels the element has. Vertical columns on the periodic table are called families or groups. And tell us the number of valence electrons the element has. Okay, I'll give you another point if you put in here that they have similar reactivity. Okay, down to number 27. Well, number 25 and 26, the best way to find that is to look at their atomic number. Okay, whenever it's neutral, your electrons are equal to your protons, which are equal to your atomic number. Okay, and same thing up here, your protons are equal to your atomic number. So you should be able to find that answer pretty easy. All right, number 27. Which element is represented by my Bohr diagram? All right, whenever you're looking at a Bohr diagram, you have your protons on top, your neutrons on bottom, and these little dots around the rings are going to be your electrons. Okay, so the best way to figure out which element is represented is you look at your proton count. Okay, so I have 13 protons. So I find something with an atomic number of 13, and that's going to be aluminum. So my element is aluminum, and that's because my number of protons was equal to 13, which is its atomic number. All right, whenever it's neutral, it has a total of 13 electrons, and since it's in group 13, I have 3 valence electrons. All right, number 28. Which element is represented by this Bohr diagram? Okay, this one I have 8 protons, so I need to go find the element with the atomic number of 8, which is going to be oxygen. All right, what's the mass number of this atom? Well, all I have to do is add my protons, which is 8, so 8p plus 8 neutrons is equal to 16. So I have 16 atomic mass units as my answer. And how did I know? I just add my protons and my neutrons to get my total. Okay, it has 8 total electrons, and oxygen is in group 16, so it has 6 valence electrons. All right, number 29. Which electron dot symbol would represent aluminum? So I need to go find my group number, because that will tell me how many valence electrons I should have on my Lewis dot diagram. Okay, so aluminum is in group 13, so I should have 3 valence electrons. Okay, so I find the one with 3 dots. That's going to be A. And how did I know? You can just write that as your answer. Group number is 13, which is 3 valence electrons. All right. Number 30. Which group or family is represented by this electron dot structure? Well, I only have 4 dots, so that means that group 14, which has 4 valence electrons, is going to be my answer. Okay, for extra credit over here, you can write your group numbers are equal to your valence electrons. So group 15 will have 5 valence electrons. All right, next page. right, first thing, here's an extra credit point. An isotope has the same number of protons, but a different number of neutrons. Okay, so number 31, carbon 12 and carbon 14 are isotopes of carbon. They both have, let's look here, carbon has an atomic number of 6, so it has 6 protons, but carbon 14 has 2 more neutrons than carbon 12. All right, the isotope of oxygen 17, oh no, I'm not answering that one. Next one. How many neutrons are found in potassium? 40. To do this, I found my atomic number is 19, and I take my mass, which is the number that's shown on this isotopic layout. Sorry. 40 minus 19 tells me I have 21 neutrons. All right, another way you can see isotopes written out is it would be 40 over my atomic number for potassium, which is 19. Okay, so I have my atomic number. Oh, sorry. I messed that up. My atomic number is down here. This is my mass. And this is my symbol. All right, I will give you a point for writing that out. All right, number 1, take a second and pause this. It says that to write in the descriptions, the arrangement of electrons in an atom is called the electron configuration. Electrons fill up the lowest energy levels first. The lowest energy state of an electron is called the ground state, and an atom's electronegativity is a measure of how much it wants additional electrons. The ionization energy is the amount of attraction an atom has for its own electrons, and your atomic radius measures the size of an atom. Lastly, electrons are found in the orbitals of atoms. Protons and neutrons are found in an atom's nucleus. So you can pause this and write that out if you would like to. That'd be good. All right, next stop is nuclear chemistry. For this one, I've created a brain dump for y'all. You can find this on my Canvas. I have uploaded a picture of it, and you can create your own, and you can use this on your final exam if you would like and if your teacher allows. Okay, so I just have 4 types of emission. I have an alpha particle, which creates a helium particle that gets emitted. A beta particle, which is an electron that's shot out from my atom, and it's able to change a neutron into a proton. So my mass will stay the same. See, my mass is 165 here and 165 here. The only thing that changes is I go from 67 to 66. All right, and then a neutron emission. I shoot out a neutron, so my mass decreases by 1. I go from 23 to 22. And then you have a gamma particle, which is a high energy emission, and it's just energy. It doesn't have any kind of mass. Okay? So what does the number stand for in sodium-23? That is our isotopic notation. So that 23 is going to be your mass. Okay? This is what I wrote up here, so you can write it down here if you'd rather. Okay? Number 2. Which particle completes the following equation for the decay of U-238? Okay, so I'm going to look at my mass first, because what I have on one side has to be equal on the other side. So I started with 238 on this side, and I went to 234 and something else. Okay, so 238 minus 234 is 4. So that means my mass over here must be 4. Okay, down here I see there's a change between my atomic number. I go from 92 down to 90. So I've lost 2 protons. So my atomic number is going to be 2. And if I look at my periodic table, the only thing that has an atomic number of 2 is helium. Okay. And my only kind of decay that creates a helium particle is an alpha particle. Okay. So it kind of looks like a sideways fish. Okay. What is one of the symbols for a beta particle? Well, you can look on here, or you can look at the back of your periodic table. That should have it as well. It's going to be 0 over negative 1 E. So that's 0 over negative 1 E, or A. So it's A. Number 4, what's the symbol for an alpha particle? Okay, that's the one I just set up here. So that's going to be 4 over 2 helium, or C. All right, number 6. Here's a little bit of extra credit. Fusion is two things coming together, so combining your nuclei. Sorry, fusion, yeah. Fission is one thing splitting apart to form two things. So you split your nuclei. So the process of nuclear fission will involve splitting the nucleus into smaller atoms, or C. And lastly, nitrogen 15 has one more neutron than nitrogen 14. Right, next page. Okie dokie, number 9. Which nuclear reaction is classified as alpha decay? Okay, so we know alpha decay is a helium particle, which looks like 4/2. Okay, and the only answer that has that is going to be A. Okay, it produces that helium particle. All right, scroll on down to number 13. Which of the following radioactive particles, in order from least to most penetrating? So for extra credit, I want you to put on this end, largest particle, least penetrating. And on this end, smallest particle, most penetrating. Okay, this means that it will go through clothes, it will go through wood. The only thing that stops it is a thick wall of concrete. Okay, so my most penetrating is going to be gamma. Think most penetrating is that harmful ray that created the Hulk. Okay, least penetrating is going to be my biggest particle, which is going to be my alpha particle. That my alpha particle is an entire helium particle. Okay, so that leaves the one in the middle to be beta, which is a B with a long arm. And we can go on to the next one. All right, for Unit 3, ionic bonding and physical versus chemical changes. The first thing I want you to put is physical changes you want to think of as the water cycle. Okay, so anything that happens in your water cycle can be undone. Chemical changes cannot be undone. Okay, so condensation, vaporizing, evaporating, melting, boiling, freezing, those are all parts of your water cycle, so they can be undone. Okay, but think about rotting. If I leave a stump out in the middle of the forest, it's going to rot away and I can't get that stump back. So that's going to be a chemical change. All right, corrosion. If I leave my, I don't know, trailer outside in the rain, it's going to start to rust. Okay, and I can't get that rust off, so that's going to be chemical. Cutting. Think about taking a stick of butter. Can I cut a stick of butter in half and have it be the same on both sides and then melt the butter back together and it's still just butter? Yes. So that's going to be a physical change. Combustion. If I explode something, I can't necessarily put that back together. So that's going to be chemical. Dissolving. If I put sugar in water and dissolve it, I can actually undo that because I can boil the water out of the sugar. So that's going to be physical. And then burning. If I burn a bunch of logs, I obviously can't get my logs back. So that's going to be chemical. Right? Next one, number 1, circle the elements below that tend to gain electrons when bonding. Okay, so these are going to have a negative charge, which are mostly your nonmetals. Okay, so let's look at this. We have, let's see. We have calcium. That's on this side of my periodic table. Everything on this side of my periodic table is going to be a metal. Everything over here is a nonmetal. Okay, so calcium's on this side, so that's a metal. Not what I'm looking for. Sodium, same thing, it's over here, so that's not what I'm looking for. Sulfur is over here though. That's in my nonmetal range, so I'm going to circle that. Magnesium is a metal because it's right there. It's over here. Bromine, Br, that's right here. So it's in my nonmetals, so I'm going to circle that one. Neon. So the cool thing about neon is it's in this noble gas range, so it actually doesn't gain or lose any electrons. It wants to be by itself. So that one is not going to gain an electron even though it's a noble gas. And then lastly we have iron, which is the middle of our transition metals, so that's a metal. Okay. Next one, circle the elements that tend to form cations. Okay, these are going to be positive metals. So basically the opposite of what I had in the first one is going to be my answers. So calcium, sodium, not sulfur, magnesium, not bromine, and iron. But neon, I just said, does not gain or lose any electrons. So that one also stays out. Okay? Number 3, oxygen has how many valence electrons? It's in group 16, so I have 6 valence electrons. It would like to gain 2 more to get to 8. So its oxidation number is -2. That's -2 because we increase the number of negative electrons in my atom. Okay, so we have more negative electrons than we do positive protons. Okay, lithium has how many valence electrons? It's in group 1, so it has 1 valence electron. It would like to lose that 1 valence electron, which would make its oxidation number +1. So this one is positive because it loses that negative electron, and it makes my positive protons more than my negative electrons. All right, what is the charge on bromine whenever it forms an ion, and why? So bromine is in group 17, so I have a charge of -1 because it wants to gain that 1 electron to get to 8. It has 7 valence electrons. All right, so it's negative because it tends to gain its electrons. All right, and then number 6, if an atom has 35 protons and 36 electrons, it's going to have a negative charge because I have more negative electrons than I do positive protons. Okay, in a neutral atom, your protons are going to equal your electrons. All right, and then for an extra credit point, I want you to write anions are negative nonmetals and cations are positive metals, and make sure you draw your T for your plus sign and your negative sign through your A. All right, next page. We're going to draw our Lewis dot diagrams, okay? Our Lewis dot structures show me the number of valence electrons. Okay? So I'm only going to do 2 of these. I'm going to do magnesium and oxygen, and you're going to do fluorine and argon. Okay? So for magnesium, I want to find my group number. Okay? Magnesium is in group 2, which means I have 2 valence electrons. And I'm going to draw those up on top. Remember, you share your bed up top before you, the parents share their bed up top before you get to your single beds. Okay, if you're interested, the setup for this, you would put dot 1 here, dot 2 here, dot 3 here, 4, 5, 6, 7, and 8. Okay, that's the placement of your dots. You would place dot 1, dot 2, 3, 4, 5, 6, 7, 8. Okay? Oxygen is in group 16. So that means I have 6 valence electrons. So I'm going to put my 2 up top and then 1 on each side. It's 2, 3, 4, 5, and then my 6th one goes back on this side. All right? Number 8. Which of the following would not have the same number of Lewis dot structure? Oh, same Lewis dot structure as calcium. Okay, so it needs to be in the same group. We need to see which ones are in the same group as calcium. Okay, so I have calcium. Beryllium's in the same group, so that's out. Lithium is over here in group 1, so that's in group 1. Let's see, magnesium is in group 2, so that's out. Barium is in group 2, and that's also out. So lithium is my odd man out, and that's my answer. All right, number 9. Metals tend to lose electrons when bonding, making them cations, whereas nonmetals will gain electrons in bonding, making them anions. Noble gases will neither gain nor lose electrons because they have 8 valence electrons already. All right, and then I have number 10 filled out for you. You can take a second and do that one. All right, and then to find number 11, all you have to do is look at your number of protons to identify your atoms, okay? Because your protons are equal to your atomic number. Okay, and then to solve for number 12, we want to find the one that's an ion. The best way to do that is find where protons are not equal to electrons. All right, and then you can fill out the rest of this page. We're going to move on to the next one. All right, number 4, what oxidation number will the following groups have? All right, if you have your periodic table, you should have your oxidation numbers written out on top already, which should be super helpful. Okay, your halogens are right here, group 17. They have a charge of -1. Okay, your alkali metals are group 1, so they have a charge of +1. Alkaline earth metals are right here, column 2. So they have +2. And your noble gases have a charge of 0. Okay. Next, we're going to complete your chart. This is for the only things that use prefixes are going to be covalent bonds only. Okay, I want you to write that in so you remember that. Okay, and your prefixes are going to be mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. All right, and I want you to make this note off to the side. Put a star next to 1. We only use mono prefix on our second element. So if I have SF, that's going to be sulfur monofluoride, not monosulfur monofluoride. Okay, so you only use mono on your second element. All right, down to number 6. We want to find the ones that are ionic, or a metal with a nonmetal, or covalent, which is a nonmetal bonded with a nonmetal. Okay, so carbon, that is a nonmetal. Usually you only have to look at the first one to tell if it's ionic or covalent, because it's going to be a metal first or a nonmetal first. Okay, hydrogen we know is a nonmetal, so it's covalent. Sodium is over here, so that's on my metal side. It's going to be ionic. Carbon, again, is on my nonmetal side, so this is covalent. Magnesium is a metal, because it's right here in group 2, so that's ionic. Barium, same thing, it's down here, so that's going to be ionic. Potassium is over here, group 1, so that's going to be an ionic bond. And O2 is just oxygen bonded with oxygen, so this is covalent. Okay. Number 7, covalent bonds occur between 2 nonmetals. In this type of bond, electrons are shared between atoms. Okay, ionic bonds formed between a metal and a nonmetal. This type of bond, electrons are transferred from one atom to another. All right, going on down. What is the name for P2Cl5? All right, this is going to be a covalent bond. Okay, because both phosphorus and chlorine are nonmetals. Okay, so that 2 tells me what my prefix for phosphorus must be. Okay, so I should have di with phosphorus. And if I look at A, B, C, and D, I can see that only C has that di prefix with phosphorus. So my answer is C. I did not even have to do the whole thing. I just did process of elimination, found that I needed di in my first word, and went ahead and got rid of the rest. All right, what's the formula for dinitrogen trioxide? Again, this is covalent because we have those prefixes. So nitrogen has a di, which means 2. So I have 2 as my subscript. And trioxide, I have oxygen with a subscript of 3. Okay, I don't crisscross covalent bonds. I just use my prefixes to tell me exactly what my subscripts should be. You also do not reduce covalent bonds. Okay. All right, so my answer is going to be D for that one, because it's in 203. All right, next page. All right, I'm only doing it a couple on this one. You can go through on your own and take care of this. For example, we got aluminum fluoride. Aluminum is not a transition metal, so I do not need a Roman numeral in my name. Okay, but if I look over here at manganese fluoride, I do need a Roman numeral because this is a transition metal. A transition metal is anything that's in the middle except for my exception block, which I have highlighted right here. You need to remember these 6 because you see aluminum? Aluminum has that designated +3 charge, which means I do not need to designate that 3 in its name. Okay? But for manganese, it can have several different charges, so I have to say exactly what my charge is going to be this time. So what I do is I take the subscript that's by my F, and that's what's going to go with my metal. So I have manganese with a Roman numeral of 2, and that's fluoride. Right? We got the same idea down here for titanium. Titanium is also a transition metal. So I'm going to need a Roman numeral for both this one and this one. Okay? So titanium, I'm going to use a subscript of 1 to go with it. So this is titanium, 1, and SO4. If you look on the back of your periodic table, you should have a list of polyatomic ions, which are ionic. And what did I say? Oh, SO4. SO4 is down here, so that's sulfate. So titanium 1 sulfate. Forgot to say that manganese is ionic as well. Same thing with this one, it's ionic. Okay? And I'm going to do the same thing with this one over here. However, I have a subscript of 2 this time that's going to go with my titanium. So it's going to be titanium 2 sulfate. All right, next section. I have diphosphorus trioxide. So I have phosphorus, and I have that di, which means 2. So my subscript is going to be 2. And oxide, which is O, and it has the tri with it. So that 3 is going to go down there. So my formula is just P2O3. All right, next one, barium chlorate. Barium is going to be Ba. And chlorate, see how it has that ATE? If you see ATE or ITE, that means that it's going to be a polyatomic ion. The rest of them are going to have that IDE at the end. So like oxide over here, or sulfide. Okay? So barium chlorate, I'm going to look back at my polyatomic ion list. Chlorate is right here, which is ClO3 with a -1 charge. So ClO3 with a -1. Barium, if we're looking at our periodic table, is over here and has a charge of +2. All right, and then I crisscross. My 2 comes down here, 2. My 1 comes down here. Not the charges, just the numbers. So I have Ba, ClO3, 2. Perfect. All right, number 21. What is the name for CaCl2? Okay, calcium is a metal. It's over here in group 2. So this is going to be an ionic compound, and calcium has a designated, oops, you can't see that, has a designated charge, so I don't need a Roman numeral. So I'm going to get rid of that one right now because it has a Roman numeral. And since I said it was ionic, I do not need any kind of prefixes, so I can get rid of that one. So I just need to decide if it's chloride or chlorate. Okay, remember I said up here, if it has ATE or ITE, then it's going to be a polyatomic ion. So that cuts that out because Cl is just chlorine. Okay, if it's just the element, it needs to end in IDE. So my answer is going to be B. All right, next one. I gave y'all another little fun one over here. I mixed calcium with sulfur. So I have calcium +2 plus sulfur -2. Those crisscross and becomes calcium 2, sulfur 2 as subscripts, and it reduces down to CaS. Okay. And next I want to find my formula for disulfur hexoxide. So sulfur has that little di with it, which means I should have a subscript of 2, and oxide is O, so it has and it has the prefix hex, which is 6. So I have S2O6. Okay, keep in mind, I do not want to reduce covalent compounds. Okay, you only reduce ionic ones like I did over here. Don't reduce covalent ones. So my answer is going to be A, S2O6. All right, go ahead and write these both in for some extra credit points. All right, also, if you don't remember how to name these, there's this foldable that is available on Canvas for you to use. This is what the front of it looks like. This side's not scanned, so you can keep this as, if you want, as a reference. But on the inside shows you how to name an ionic compound and a covalent compound. Okay? Even includes your prefixes down here. All right, next page, last page. Yeehaw. All right. Number 1, in a chemical equation, the number written in front of the chemical formula is what? It's the big number that's written in front. Okay, if you don't remember this lower number that's down here is called a subscript. And if you see O with a charge of -2, that's called a superscript. Okay, think of the term Superman flies up high. So that's going to be your high number. And subscript is like subterranean, so that's below ground, so it's going to be below your thing. Okay, that leaves only one word for this one, and that's going to be your coefficient. All right, a balanced chemical equation is a direct representation of the law of conservation of mass. Okay, number 6. This is where you can do types of reaction brain dump. It includes everything up into acids and bases. So you have synthesis, which is 2 things coming together to form one. Decomposition, which is 1 compound decomposing into its single parts. Single replacement will always have a single element on each side. Double replacement will have double compounds on each side. Combustion is always CH reacting with O2 to produce CO2 and H2O, which is carbon dioxide and water. And neutralization, which we just learned, is an acid, which has hydrogen, and a base, which has hydroxide, reacting with water, and salt, which is just a metal and a nonmetal. Okay, this picture is also up on my Canvas, so you can print it out, or you can write your own out. You need to have a handwritten one for your exam, though. Okay? So let's look here. A, we have a single element on both sides, so this is going to be single replacement. B, we have 1 compound decomposing into its separate parts, so it's decomposition. C, we have CH reacting with O2 to produce CO2 and H2O. This is going to be combustion. D, we have double compounds on each side, so this is going to be double replacement. And E, we have 2 elements coming together to form 1 compound, so this is synthesis. All right, going up. If we're going too fast, tell your teacher to slow down. I'm sorry. All right, number 8, or pause it yourself, I guess, if you're watching this at home. We need to balance these reactions, tell what type of reaction it is, find my ratio of coefficients, and answer A, B, and C. Okay, so the first thing I'm going to do is balance this. So I'm going to list out the elements I have on each side. On this side I have silicon, oxygen, hydrogen, and fluorine. Again, I have that over here, silicon, oxygen, hydrogen, and fluorine. All right, I just like drawing my dots. Okay, so I look at my subscripts to tell how many I have of each element. Silicon doesn't have a subscript, so I assume that there's 1. Oxygen has 2 as its subscript, so it has 2 of those. Hydrogen, I've got 1 of those, and fluorine, I have 1 of those as well. On this side, I have 1 silicon, I have 1 oxygen, I have 2 hydrogens, and I have 4 fluorines. Okay? Sorry, that's a bad 4. All right, so the first thing I want to do is I'm just going to go down the line. Oxygen, I have 2 over here and 1 over here. I like balancing my reactants first and then going back to fix my products. I'm sorry, I like balancing my products first and then going back to fix my reactants. Got my words mixed up there. Remember, reactants, react to produce products. That's just my little saying. Okay, so I'm going to fix oxygen first. I want it to be equal to 2, so I'm going to multiply the compound that it's in by 2. And I have to distribute that to both elements. Okay, so 2 times 1 is 2, so I have 2 oxygens now. And 2 times 2 is 4, so I have 4 hydrogens now. So I have 1 silicon, 2 oxygens, and I need to fix hydrogen to have 4 and fluorine to have 4 on this side. Okay, this is pretty easy because if I look on this side, I can see that hydrogen and fluorine are actually together in a compound. And they're both equal to 1 right now. So all I need to do is multiply that by 4 and distribute it to each one. So each one is now equal to 4. So I have 1 silicon on each side, 2 oxygens on each side, 4 hydrogens on each side, and 4 fluorines on each side. So we're balanced. If you don't have a number there, in the front of it, you can assume that there's a 1. Okay? Also, since I have double compounds on each side, this is going to be a double replacement type of reaction. Double replacement. All right, and I said earlier up here that my coefficient is the big number in front. So my ratio of coefficients is just 1 to 4 to 1 to 2, because it's my big numbers. 1 to 4 to 1 to 2. All right, what is the coefficient for hydrofluoric acid? Okay, this is going to the unit we just learned. Hydrofluoric acid is a binary acid because it starts with hydro and ends with acid. Okay, so the only thing that starts with H and in the compound and has fluorine at the end is going to be HF. So HF has a coefficient of 4. Okay, how many moles of silicon tetrafluoride are there? Okay, silicon tetrafluoride is going to be this one right here, SiF4. And I have a coefficient of 1, so that tells me I have 1 mole. Okay, what's the mole ratio of silicon dioxide, that's SiO2, to water, which is H2O? And I look at my coefficients. SiO2 has 1 mole, and water has 2 moles. All right? Now let's go down to number 9. 9 is CH reacting with O2 to produce CO2 and H2O. The only kind of reaction we have that produces CO2 and H2O is a combustion reaction. Okay? And combustion reactions have a rule that you can kind of follow to help you solve for it, because we have oxygen split up into 2 things over here, so it makes it a little bit difficult. My little rule is I solve O2 last. Okay? You want oxygen to be even on this side to find O2 over here. Alright, so the first thing I'm going to do is list out my elements on each side. I have carbon, hydrogen, and oxygen on this side. And I have the same 3 on this side, carbon, hydrogen, and oxygen. Okay, over here I have 3 carbons, I have 6 hydrogens, and I have 2 oxygens. Over here I have 1 carbon, I have 2 hydrogens, and I have 2 plus 1, 3 oxygens. Okay, you have to make sure you include both oxygens over here. Okay, the first thing I'm going to try to fix is, let's see, I have an odd number up here, and what I like to do is I like to make everything even on one side before I move to the other. So what I'm actually going to do is I'm going to multiply carbon by 2. That means I need to put a coefficient of 2 up here. Distribute it to both here and here. 1 second. I put my 2 in the wrong place. I'm sorry. Ooh. Okay. So I want to multiply 3 times 2, which is 6. Okay, and then 6 times 2 is 12 total hydrogens. Okay, so now I have an even number on this side, and I can go ahead and move on to this side. Okay, so to make carbon equal to 6, I need to multiply it by 6. So I found the compound that has carbon in it, and I'm going to put a coefficient of 6 there, and distribute it to both carbon and oxygen. So 1 times 6 is 6, and 6 times 2 is, 12 plus the 1 over here, so 13 oxygens. I didn't mean to cross out my hydrogen yet. I still have 2 hydrogens. Okay. Next I'm going to fix my hydrogen, even though I just crossed it out. I need to have 12 total hydrogens, so I'm going to multiply that compound by 6 and distribute it to both elements. So 2 times 6 is 12, and 6 times 2, if I'm finding oxygen, 6 times 2 is 12, plus 6 times 1 is 6, so that's a total of 18. So I have 18 oxygens over here. Notice I have an even number on this side, and that makes it easy to solve for my oxygen, my O2, very last. Okay, so to get to 18 oxygens on this side, I need to multiply that by 9. Gives me a total of 18. Okay, because 2 times 9 is 18. All right, so my ratio of coefficients is just 2 to 9 to 6 to 6. Cool. And number 11, the very last one at the bottom. How many atoms of oxygen are there in Cu3PO4? 2. I take that 2, and I'm going to distribute it to both elements. So technically I have 2 phosphoruses, and 2 times 4 is equal to 8 oxygens. So my answer is C. All right. So part 2 will be up hopefully later. Good job, guys, and good luck.